Assalamu alaikum. Welcome to our presentation of the research work Deep Learning Based Bangla Voice to Braille Character Conversion System. I am Soid Bais Iqbal and I would like to thank my fellow authors MD Akif Hussain, Riazul Islam Rifat, Simon Bishas, MD Ghulam Robiul Alam, and MD Tanjim Reza for making our research work successful. I am going to cover the introduction, research problem, and research objective. To begin, Bangla is one of the most spoken languages in the world. More than 300 million people use Bangla as their first language. It's a very challenging matter for visually impaired people to learn Bangla at an early stage. And here comes the Braille system for visually impaired people to overcome the challenges of learning. A single Braille cell contains 6 raised or flat dots, 3 dots on the right and 3 on the left. A single Braille cell can form 64 different patterns, including empty patterns. Each dot pattern represents a letter, a combination of letters, numbers, symbols, etc. A different language has different types of Braille patterns. For different Bangla primary characters, there are in total of 50 Braille patterns. However, in the modern education system, Braille is not incorporated that much. As a result, visually impaired people are lagging behind at the very early phase of their academic life. Here, voice to Braille character pattern conversion using deep learning like voice to text conversion will be a great opportunity for visually impaired people to overcome their challenges in the case of a character learning at the early phase of education. Now, coming to the next part, which is research problem. Due to a scarcity of textbooks and other reading materials written in Bangla Braille, visually handicapped people in Bangladesh are denied access to education and a contemporary technology. To make a significant difference in this situation, the model that we are going to develop is for the visually impaired people, by which they can start their initial education on Braille patterns. This model is going to convert the Bangla character from the recorded audio to its corresponding Braille pattern. This model will focus on Braille education. The main goal of this model is how a visually impaired person can learn Braille patterns. For our work, first, we will collect the dataset which consists of recorded audio of all Bangla alphabets. Then using voice recognition, the recorded Bangla characters will be identified. Now, the research objectives. Our research aims the development for the visually impaired people to start their basic education with a technology that will be capable to recognize a Bangla character uttered by a person, and after that the character can be converted into a Braille pattern so that using the touch of a finger a visually impaired person can understand the corresponding Braille pattern of that character. The objectives of this research are as follows. Firstly, deeply understand the Braille pattern. Secondly, understand how the Braille pattern is helping visually impaired people. Next, develop technology for Braille education for visually impaired people. Moreover, to evaluate the technology developed for visually impaired people. And finally, to offer recommendations on improving the model. That's all from me.
Assalamu alaikum. My name is MD Akif Hussain and I'm going to cover the literature review or some previous work related to our research and the work plan part. So the first paper that I'm going to talk about deals with conversion of handwritten Bangla character to real-time Braille using image processing and machine learning. This work has been done in two parts. Firstly, an image of an handwritten Bangla character is taken and then applying the concepts of image processing using machine learning, the captured and processed image of the recognized character. Then the recognized character is passed necessary hardware devices which process the data and presents in real-time Braille pattern of the corresponding character on the LCD monitor. The second research paper that I'm going to talk about deals with scanned Hindi handwritten text into printable text using Hawk features with SVM classifier and then maps the printable text to Braille. So this work first convert the characters to remove the overhead lines of the Hindi characters, and this is done by adding pixel row wise. After that, the segmented character are recognized using the SVM classifier and converted into a binary image. The classifier is trained on Hindi consonants and the test is done on handwritten Hindi words. Although there has been less research on Bangla character conversion from voice, the third paper that we are going to discuss proposed a device that is voice activated Braille portable device. The purpose of this device is to help visually impaired people to recognize certain characters without any other partial help. We have read two more papers related to our research work. One is about an inexpensive portable communication device designed to convert all Braille input into alphanumeric character. The task of this paper is achieved in two parts. One is a Braille to text converter and another is a Reese vibrator for giving input. The other paper elaborates on a method of converting documents in Braille into text files. The paper depicts a method where Braille cells are segmented and then extracted. Afterwards, the cells are converted into number sequence. Then this number sequence is mapped to the respective alphabets. So now let's look at the work plan of our research work. We are doing our research work following a specific plan in order to achieve our goal. First, we have collected our data sets of recorded audio of Bangla alphabets irrespective of age and gender. After collecting data, we started processing our data sets utilizing audio to spectrum conversion and classification. Then we tested our data sets. Afterwards, we traced it and trained our algorithm as well. We have designed a process for taking our input data and processing the input data into two prediction fields. One is correctly recognized, another is incorrectly recognized. Correctly recognized means our algorithm is recognizing Bangla alphabets properly. We will use Arduino, LCD monitor and hardware particles to print Braille language pattern. In the data processing part, we have three parts. First part is input data processing, then processing, and finally prediction. Input data processing is required if data encoding is needed. In processing part, we are doing clustering and classification of our data by using CNN algorithm. The prediction part gives us results that are found after testing the datasets. We are using 70% of datasets for training and 30% of datasets for testing. Finally, we get the accuracy based on whether our system can recognize the Bangla alphabets correctly or not. And we can achieve better results by increasing the number of datasets. That's all from me for now.
Assalamu alaikum. I am Riyazul Islam Rifat and I am going to discuss from input data methodology to spectrogram classification. Input data methodology. The flow is data collection, format conversion, data labeling. I am going to discuss all of the points. For our data collection, we have taken voice samples from people around us using voice recorder software. Our data mainly consists of 11 vowels. Shorborno, we have taken each vowel 10 times from an individual person. We have collected around 25 sets of data and there are more than 2,500 records. Around 1700 data is for training and around 700 data is taken for testing. Here this picture depicts the percentage of men, women and children whom we collected data from. Our collected data were in M4A format. That's why we converted the data into WAV format and then we started data labeling. We labeled our data in a separate folders following the naming format character nong, underscore person nong, underscore record nong. We labeled our character from 0, that means Shoreo is labeled as 0, Shorea is labeled as 1 and so on up to OS 10. For example, here in the picture, 1 means character Shorea and it is the age number of recording from person 25. Data preprocessing. In this part, we mainly focus on audio spectrogram conversion. Before discussing on that, there are two pictorial representations of our data. These picture represents 150 records of individual data and this the duration of data recording. Then we generated frequency spectrum for all individual data. To do this, we have accessed WAV files using OS listdir and created two separate lists for our train data and test data. Then we have generated frequency spectrum for all the individual data of those lists and saved all the train and test spectrogram in separate directories for further classification. We have used a sample rate of 16,000 to generate frequency spectrum. Here is the sample of a spectrogram image. It represents the frequency according to time. Now, spectrogram classification. The steps for spectrogram classification are shown here. I am going to discuss all of this one by one. Model initialization. We have used BGG16, which is a convolution neural network architecture to initialize our model. To create our model via BGG16, we have considered the initial input shape 256 multiply 256 multiply 3. We have set include top false as we fitted the model on our own problem and set words ImageNet as we need to load the pre-trained words of BGG16. Then we have created object of image data generator for both train and test with a batch size of 32, and in that case the input shape was 256 by 256, and we got 1701 image belonging to 11 classes for training and 726 images belonging to 11 classes for testing. Then we added different layers to the model such as conv1, conv2, maxpool, etc. Here is the pictorial representation of different layers that we fitted to our model. Then we flattened the layers of our output model to pass the data to dense layer using Rayleigh activation and softmax activation. After the creation of softmax layer, the model is finally prepared. Then we compiled the model. After compilation of the model, we measured loss and accuracy for train and test data, and in that case we got 98% train accuracy and 92% test accuracy. Here is the sample of our class indices here, and this is the pictorial representation of our train test accuracy. That's all from me.
Hello again everyone, this is MD Akif Hossain. So after getting accuracy, we are mainly checking our model by inserting random spectrogram data in our prediction file. This random spectrogram data belongs to Bangla vowel. Then it is giving one hot vector or output array after detecting the character successfully. Then we are inserting the output array as input array. In that array, only one index value will be 1 and all other value will be 0. For example, we inserted here the spectrogram of Shore A, and the value of the index number 1 over here is 1. So it is successfully detecting Shore A, as Shore A belongs to class 1. So the value of index 1 over here is only 1 and the rest other values are 0. Now I'm going to discuss the simulation part of our research work. In our Arduino code, we have imported liquid crystal library as it allows an Arduino to control LCD. Then we wrote our Arduino code in a way so that it can generate only the Braille pattern of the character for which output arrays index 1 was 1. After that, we generated the .hex file from our .ino file. Then this .hex file was imported in our Arduino Uno as source code. You can also see the successful compilation of our Arduino code, and this is our .hex file over here. Moving on to our next slide. We have used Proteus as our simulating software. In the Proteus, we have used Arduino Uno, LCD16x4 display, pot HD, power source and ground, and these wires over here connect the Arduino Uno to the LCD. Then after running the simulation part, it generated desired Braille pattern in LCD. For getting our desired result, we inserted Shore A in our prediction part, so it generated Braille Shore A that we can see over here in the display, and this Shore A corresponds to the Shore A of this image. So we can see that our Arduino code is working properly. Now if we move on to our next slide, we can see that these are all the other Braille characters that we have generated by using our Arduino. Now I'm going to discuss the conclusion part of our research work. We focused on voice to Braille conversion in our research work. If we summarize, we have collected the data set in M4A format and converted it into .wave format for the ease of our use. Then we have done audio to spectrum conversion, then spectrogram to Braille conversion. Our main motive of this research work was to make education easy for visually impaired people. In future, we want to replace our simulation part by hardware implementation, so this research work comes in real world usage of the visually impaired people. That's all from us. Thank you.